Hello, welcome back. This is Miss Sheldon. Today we are going to be going through the basic trig functions foldable that looks like this. So go ahead and open up to your top right-hand corner under basic trig functions. And today we're going to be talking about the trig functions sine, cosine, and tangent. So if we have a triangle here, this is a right triangle, we're going to look specifically at angle A. We have our hypotenuse, we have the short leg, the long leg, and we're going to identify this segment BC as the leg opposite to angle A. So the leg that is across from angle A is the opposite leg. This is going to be abbreviated as OPP or O, for opposite is this abbreviation. The leg that is right next to this angle is the leg adjacent to angle A. So this leg right here, CA, is adjacent to A, and we're going to abbreviate adjacent as ADJ or A. Our hypotenuse we can abbreviate as HYP, and that can also be abbreviated as H. And our trig functions sine, cosine, and tangent can be abbreviated as SIN, COS, and TAN. Do not call them sin, cos, and tan though. We refer to them as sine, cosine, and tangent. Every time you say sin, cos, and tan, a mathematician dies. Okay, let's go ahead and look at sine. So move your foldable over and open up the top left flap. So sine is going to be equal to our opposite leg over the hypotenuse. Opposite over hypotenuse. So what does this mean? Well, if we have our angle D, sine of D is going to be equal to the opposite leg, which is 7, over the hypotenuse, which is 25. When we simplify 7 over 25, this gives us 0.28. What is sine of angle F? So our leg that is opposite of F is 24, and our hypotenuse stays the same, that's 25. And when we simplify that, that gives us 0.96. So we can use sine, cosine, and tangent to find missing side lengths of a triangle given one angle measurement. So here they give us 65 degrees and they want us to find t. So if we have sine of 65 degrees, this is going to be equal to the opposite leg, which is t, over our hypotenuse, which is 8. Now we can solve for t by multiplying both sides by 8. So I get 8 sine of 65 degrees equals t. Now I'm just going to plug what's on my left side of the equal sign into my calculator. And when I plug that in, I'm going to get 7.3 approximately t. So there should be a button that says SIN with parentheses. You'll just type in 8 times, hit that button, type in 65, close your parentheses, and equal to. And that should give you 7.3. If you come up with a really funky number or something that has pi in it, you're probably in radians, not in degrees. So you'll have to go to the mode button of your calculator and change it from radians to degrees. And if you have a problem with that, I would Google it or come talk to myself or Mrs. Radke and we can help you out. Okay, so before we talk about writing cosine in terms of sine, let's come down and look at cosine. So cosine is the adjacent leg over the hypotenuse. So same thing, we're just going to write out our proportions here. So if we're looking at angle D, then the adjacent leg is 24, and that's over our hypotenuse, which is still 25. And when we plug that into our calculator, we will get 0.96. And angle F is adjacent to 7. We're going to put that over the hypotenuse, which is 25, and that's going to be equal to 0.28. So now you can see here that sine of D up here gives us the same value as cosine of F. Well, think about it. Sine of D here is this leg, 7 over 25, and cosine is also 7 over 25. So when we write sine and cosine in terms of each other, we do this by subtracting our angle measurement from 90 degrees. So if you turn your foldable, it says write cosine of 65 in terms of sine. So we're going to write cosine of 65 equals sine of 90 minus 65. So that will tell us that cosine of 65 degrees is equal to sine of 25 degrees. And when we go back to looking at this triangle here that we started with when we're looking at sine, we know that all triangles add up to 180 degrees. So 65 plus 25 plus 90 equals 180. So that helps us see why we're subtracting from 90 degrees in order to put it in terms of cosine or sine. So here, let's go ahead and write sine of 23 degrees in terms of cosine, and then we'll go back and find that missing side length. So we have sine of 23 equals cosine of 90 minus 23. That's going to give us sine of 23 degrees is equal to cosine of 67 degrees. So now let's go ahead and go back to this practice problem and find u using cosine. So we're given the angle measurement 65. So we're going to say cosine of 65 degrees is equal to our adjacent side, which is u, over the hypotenuse, which is 8. So same thing, we're just going to multiply both sides by 8. That gives us 8 times the cosine of 65 degrees equals u. And I'm just going to plug that into my calculator, and that's going to give me approximately 3.4. Okay, now we're going to look at our third trig function, which is tangent. So go ahead and open up that bottom left flap. Tangent is opposite over adjacent. So here we're given all 3 side lengths and no angle measurements. So we can use tangent. So tangent of angle J, here's angle J, is going to be the opposite, which is 24, over adjacent, which is 32. When plugging this in, that's going to give us 3/4 or 0.75. Tangent of angle K. 32 is opposite of angle K, and 24 is adjacent to, so we're putting opposite over adjacent. That gives us 4/3 or 1.3 repeating. So now we're going to look at some examples. We want to find x. So here, if I take tangent of 32 degrees, I can set this equal to the opposite side length, which is 11, over the adjacent side length, which is x. So now I'm going to multiply both sides by x, and I get x times the tangent of 32 degrees equals 11. And then to get x by itself, I'm going to divide both sides by the tangent of 32 degrees. So I'm going to get x, those cancel, x equals 11 over tangent of 32 degrees, which is approximately 17.6. So we have one more example problem. Here we're going to look at x again. And I'm going to go ahead and label my sides opposite and adjacent. So here, this was O and this was A. Here, given angle 56 degrees, x is going to be opposite and 13 is adjacent. So when finding x, we're going to say that tangent of 56 degrees, looks like 560, 56 degrees is equal to opposite x over adjacent, which is 13. I'm going to multiply both sides by 13. So I get 13 times the tangent of 56 degrees equals x. I plug that into my calculator, and I get that 19.3 is approximately x. Okay, I will be going over angle of depression and angle of elevation in the next video. Thanks for watching. I will see you in class.